Hello, everyone. My name is Daniel. Today we have Beisaron, right?
Yeah.
Great. And we will talk about Helm in unicorn and big companies. I'm really excited because it's one of my favorite topics. Um, the only one thing before, are you ready, by the way, for the talk for the beginning?
Me,
Yeah,
obviously. I'm excited and ready. Yeah.
great. Um, I just have only one question. You wrote here in description, this deep dive will take us through some dark places, adoption struggles, and scary unknowns. Should we put some kind of label, for the kids 15 plus, like something on this talk?
I think it's scarier for adults. I don't think the kids will be scared of that.
Okay. So on that happy note, stage is yours, and
Okay.
I'm taking myself out. Good luck.
Right. Thanks. Okay, so I guess now is a very, very good time to start. Yeah, so how a unicorn migrated from an in-house solution to Helm. That's our talk for today. But before I go that to talk about that, let me present myself. My name is Beisaron. I'm from Israel. I was a backend engineer for over 5 years. And almost 2 years ago, I joined Forder as a DevOps engineer. I've been writing in Clojure, Node.js, Groovy, Python, and literally any language that you throw at me, I say, bring it on. I'm an international public speaker. I talk about functional programming, closure, algorithms, game development, and DevOps. And I'm also a mentor, which means I love helping other people become technical public speakers. So if you want, you are more than welcome to ping me, and I promise to help. And yeah, I'm a sworn Star Wars fan. Obviously, you can see that by the Unicorn BB-8 here on the side and by all of the things that I have around me. And yeah, but it's not going to be the theme for today. Our theme for today is going to be unicorns. And now you're going to ask yourself, unicorn, why? So that's because a unicorn, other than being an amazing imaginary creature, as far as we know, a unicorn is also a privately held startup company valued at over $1 billion. Ta 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 ta. And why do I, bother of mentioning that? It's because Forder is considered a unicorn company. As I mentioned, I've been working there for almost 2 years, and Forder is a fraud prevention and protection for digital commerce. A bit of numbers about Forder: we have around 500 employees. Out of those, we have 120 engineers, around 20 engineering teams, 400 microservices. And now you're going to ask yourself, okay, why do we need all these numbers? Well, that's because today, we're going to talk about the big project of bringing Kubernetes to Forder, but we're going to focus on Kubernetes manifest configuration. And with that, I want you to have those numbers in mind because that's what I had to do. When I had to think about the tech stack and the architecture, I had to take into account those numbers that I mentioned because providing a solution for 120 developers is not like providing a solution for 10 developers, right? It's going to be different. It's going to be different if you have 10 microservices or if you have 400 of those. So I think now is a good time to dive into the talk. So, as I said, we're going to talk about the journey for defining the Kubernetes manifest configuration. I will first start by giving you a few words about Helm. What is Helm? And then I will talk about why we chose Helm for the Kubernetes manifest configuration. After that, I will talk a little bit about charts management and how we chose to do the charts management in Forder. And then we will go over some alternatives for chart management. We will talk about our entire solution for Kubernetes, and I will talk about the CI/CD pipeline. I will talk about the solution for how we store our charts, and yeah, I think now is a good time to move forward to talk about what is Helm. So what is Helm? So Helm is simply put, it's a package manager. It just like Yum or APT or Homebrew, it's a package manager for Kubernetes. But literally, what Helm is doing is streamlines installing, upgrading, fetching dependencies, and configuring deployments on Kubernetes with simple CLI commands. So just think about it that if you had to configure all of the Kubernetes configurations yourself, you will have a bunch of files that you need to manage yourself. But maybe you don't want to manage everything yourself or create everything yourself from scratch. And this is what Helm is providing to you. So by the fact that Helm is a package manager, it not only provides the installing and upgrading, it also provides some open source Helm charts. And in order to understand how good it is, let's talk about what is a Helm chart. So let's say we have a single service, some front-end service, and we want to have that deployed on Kubernetes. What we will need in order to deploy that on Kubernetes, we will need things like deployment, service account, and then we will need all kinds of values. For example, we want to have the value of the image URL that we're going to use, the image of the Docker container that is going to run inside the pod. We will want some pod configurations. All of that will go into the values and to the templates. And last thing that we will have is the chart YAML file. In the chart YAML file, we define the name of the chart and several dependencies. If we have those, we define also versioning and other things that we want to have to define the chart itself. So why Helm? I mean, now that we need to define the Kubernetes manifest configuration, there are a few alternatives to Helm. So before we talk about the alternatives, I think it's most important to define the requirements that we had. So obviously we started with some technical requirements. Now, there were some technical requirements that were related to the existing system that we had, because obviously Forder was already a company for, up and running for a few years, and we're not starting from scratch. So there are those technical requirements, but there are a few more technical requirements that come from the reason that Forder is a unicorn company, and we need to have some compliance, we need to have GitOps, and we need to have some testing. So all of those are pretty basic, pretty understandable. But technical requirements are not the only requirements that we're going to need if we choose a different way to configure Kubernetes manifest. So here it is. When you develop an engineering platform, it is very, very different than when you develop a customer-facing product, like a company customer-facing product. And here's why. Because if you get a requirement for some new feature and you're backend developer of the product of the company, then the feature requirement will not say anything about the implementation details. They will say, oh, we want a new API integration, or we want a new data pipeline to be performed. But they won't say which library you should use. And that's not the case when you're developing an engineering platform. Because as an infrastructure developer, the code that I write, that will be the product that my users will eventually use. So I do need to think about the implementation that will fit my customers' needs, which are the developers. So there are some user experience requirements. Some of those are presented over here. For example, I wanted to have support for shared libraries. So if one developer created some feature for Kubernetes, for example, handling secrets, maybe this developer wants to share that with some other teams, so there won't be code duplication. Another thing is to have good level of abstraction for users. I don't want the users to have to handle things that they're not really interested in. But on the other hand, I want it to be easily extensible. So for the advanced users, if they want to do more things in the solution, in configuring things on their own, I want them to be able to do that without approaching DevOps, or at least without approaching DevOps when it's just an idea. I want them to be able at least to play around and try things on their own. So now that we have the requirements, let's see the alternatives that I first had. So the first alternative was to go with the in-house infrastructure as code solution that we have already written in Python. This should kind of remind you of if you're configuring things with Terraform or Pulumi, we're configuring our cloud resources with Python DSL, and we could have just add a Kubernetes manifest to be rendered with the same Python code. And to be more specific, we could have used CDKS to do that. And this would have been pretty easy for implementation. And the other option was to go with some industry standard tool and not stay with the in-house solution. And I've examined several other industry standard options, but we decided to focus on Helm. So if we look at the solutions comparison, we will see over here that I compare between the level of abstraction for users. I show how extensible it is for the users, support for shared libraries, and ease of integration with the current state. Now, I think that from this table, you can totally figure out that the in-house solution is just easier to develop, and the Helm solution provides a better developer experience. Now, when I say that the Helm solution provides better developer experience, that's what I thought. I mean, as a former backend developer and today infrastructure developer or DevOps, I thought that it provides better developer experience. But again, I'm not a backend developer at Forder today. So I can't make the decision for my users. If I want to make the right decision, I need to make the right decision for the users. And how do I know? How do I know what is the right decision for them? I should just ask them. Because DevOps means that your customers wear the same company hoodie as you. It means that you will see them in the kitchen. So, if I want to know what they think about something, all I have to do is ask. So I published an architecture design review document and I asked all of the users to comment on that. I also published a Helm preview presentation. I did a short video with a Q&A session, and I showed them a POC of how they will use Helm. It's not that I showed them a POC that says, oh, Helm works. Well, obviously Helm works. I mean, if it didn't work, nobody would have chosen that as a solution, right? But in that POC, what I did was I showed the developers what their day-to-day is going to look like once they start using Helm. So after we had those discussions and we opened a Slack channel, all of the developers, or at least most of them, they said that they are interested for us to go with Helm. So that's what we did. So the next thing after deciding to go with Helm would be to think about the chart management. So if we take a look at a small example, you know how previously I showed you that if you have a single service, all you'll need is one Helm chart. And actually, if you go ahead and look at some Helm tutorials, that's what you will see. All of those Helm tutorials, they'll be like, oh, what you need to do is that just to do Helm create, and you'll have that one chart, and then that's it. But those tutorials, they don't talk about the real world. They don't talk about what happens when you have so many services. And even this example with like these 4 services that we have, like front end and back end and the closure open source event handling service that I just added in, even that is not really a good representative of what we have today at Forder, which, remember, it's 400 services. So we need to think about a good way to doing the chart management in Helm. So what are the alternatives that I saw that were out there? So actually, there were 2 alternatives. One is called umbrella chart and the other is called individual charts. Now, the difference between the 2 of those, and that's what you will see in just a few slides from now, you will see that the main 2 differences is first, where do the chart reside? And second, how many deployments you will have to do. And this is a big thing because it means that if the charts are scattered around in many different repos, on one hand, it means that you can have like a better granularity when you do deployment. But on the other hand, it means that you will have code duplication. But if you have one chart that contains many other charts, it can come to the point where it's so complex that it's hard to navigate in that code. But this is just top level. Let's dive in and see each of these options, and then we'll talk about what I actually chose. So, Helm chart, Helm umbrella chart, and I wanted to write the one chart to rule them all. Haha. Lord of the Rings. I don't know. Maybe am I too geeky? I don't know. It's too late for that. I am too geeky. So anyway, in umbrella chart, the way that it goes is that you have one chart that where you'll, or it doesn't even have to be exactly one chart. You can also have just one repo where you manage multiple subcharts and everything goes within a single deployment. As you can see, I put all the charts in one place, the front end, the data processor chart, the API gateway chart, everything is together, and that will be deployed with a single command of Helm apply. And what you can see, as I mentioned, that each child chart represent a component of the overall application. And this chart can manage the dependencies between the child charts and can ensure that they are deployed in the correct order. Another good thing about that is that it's easy to have changes across all of the charts. So it's easy to maintain consistency in your charts if you have them all in one place. Another thing is that you can prevent from unexperienced hands touching places that they are not supposed to touch or change. And this is where it takes us in terms of, developer autonomy, DevOps responsibility. And I mean, maybe I could have put the umbrella chart a little bit below, or maybe like give it a little bit more developer autonomy, because you can handle that. You can have the developers get some autonomy. And that's exactly what we have today. We do have a mono repo, like for all of the cloud resources, all of the developers, they have to do changes in one place. But it still is mainly the DevOps responsibility. Now, the problem with that is that when you have such a big company and so many developers, in such a situation, the DevOps might become a bottleneck. So if there is a request for a new feature or support something new, then they will have to wait because maybe there are other 10 requests and maybe we still need to handle many other things, right? So having the responsibility almost fully on the DevOps side, this could be kind of problematic. So I think we all understand that we're not there yet in terms of choosing the right path. So let's go to the second option, having just individual charts. Now, what does it mean? Manage each microservice as a separate chart, each with its own values and dependencies. This means that we get the granularity in the deployment because we don't need to deploy everything at once. And something that I did not mention, which is why the umbrella chart was not such a good fit for Forder, is because we have those 400 services, and most of them are not connected in any way. Some of them are connected, obviously, because we have some, subsystems in the big system of Forder, but they all are very different in terms of resources. Even in the deployment procedure, they are different from each other. They have different authentication requirements. They have different security requirements, logging, all of those. And it is possible to solve that when you have one big chart or all of the charts in one repo, but it still will be easier to have, the specifics if you have separate charts for every microservice. And I think that you can already see the problem. Like if you look over here and you will see that each chart over here represents a single service. So first of all, remember how I said that the two options, they are different in terms of where the files are. So over here in this deployment, in this way, the chart will be with the service repo. And it means that in order to deploy, we need to have a deployment for each service separately. So even if we do want to have some dependency or some ordered deployment, this is going to be kind of hard to do that. It will require more work on our side in the CD pipeline. Another problem with having complete separate charts is the fact that if I developed some way to configure config maps, or if I did something to configure secrets or something for monitoring, then I would have to go and duplicate that code for each and every chart. And I think that we all understand that it's not fun at all. And that's an understatement. So if we go back to that nice graph, I know I'm saying that it's nice and I created the graph, but I can say that I created something nice. Who are you to stop me even? No, joking. So yeah, if we go back to this graph, we will see that the individual charts, they stand like strongly on the developer autonomy. But here's the question again. Do the developers want all of this autonomy? Do they want to be able to do everything on their own? I think that they have enough work as it is, and that they're not sitting waiting around for more tasks to come from the DevOps team. So therefore, it's not good enough. So this is where we stand right now. And I think that you can all see where I'm going with it, right? Because if I have one thing over here, I said it's not good enough. The other thing is on the other side. I also said it's not good enough. Then we want to find a good place in the middle. And we did. Spoiler alert, we did. We found a good place in the middle. And our solution is not so popular. I didn't see any records of this being done. It does not mean that we're the only ones in the world doing that, obviously. So if any of you will feel that you have something that is close to what we did at Forter, ping me. I'd love to talk about that. But I keep on saying the solution, but there is still a question mark. Now it's time to finally show you the solution. I think you're already also eager to see that, right? Yes, I'm sure you are. So subcharts was the feature that we used. It's not the solution itself. It's a feature that enabled us to go with the solution that we finally have. But what is a subchart? A subchart means that there is a parent chart that reference another chart in the chart YAML. And you can think about it just as a dependency for every library that you have. For example, like in Python, if you have dependency on libraries, or with Node.js, you can also have some dependencies on some libraries. And that's the same thing over here. So all of our services in every single chart had a subchart in their dependency, and it was all the same subchart. So every service had a single chart, and we had a subchart that was referenced by all services. So let's see how it goes. So we had chart per repo. So every service or component in our system had a Helm chart in their own repo. And they all referenced the same subchart. And I'm sure you're all wondering, how did we name that subchart? We named it Chartmender. Haha. I thought it was clever and funny. I hope you think so too. So our subchart is called Chartmender. And I think the real magic over here happens with the fact that each chart can take and override values that are defined in that subchart. So for example, we defined for all of the services some sidecar for logging and matrix. But if some service decided that they want to have a different way to do their logs, then they can just override it and not use what we offered them. Another cool thing about this way is that we offered a simple chart creation from scratch. So, for example, if you create a new service, it comes already with a chart, with a simple chart built in. So there isn't a lot that you have to do. So that's our chart management. We have one subchart, and that is being referenced by all of the other chart, and we have one chart per repo. So now that we have the chart management, the next thing was just building the entire solution. Because we're not starting from scratch. We do need to integrate with the existing systems that we have at Forder, and I'm going to show you how we did it. So I'm going back to showing you now how it actually looks like. And now I already revealed the name of Chartmender. I hope you're all smiling there. I can't really see you, but I'm going to guess that you smiled because there's a Chartmender on the screen right now. Okay. Drama moment ended. So we have let's say we have some single service, and like I said, there is the repo of the service, and in there you can see that we have the chart YAML, the values YAML, the templates, everything of this chart. But here's the thing. The chart YAML and the values YAML, they are using values that were defined in the subchart in Chartmender. And the templates the templates folder is initially empty. If the user wants to add templates, they can. They're welcome to do that, but they don't have to, because the way that we did it is we defined everything already in this subchart. And the users, if they want to keep it simple, they can just define values in the values YAML. For example, the image URL, they can define the port that they're exposing. They can define how many replica, their replica count. All of these things they can define in the values YAML. And if they want, they can also add some their own templates, but they don't have to. So we have that for one service, and we have them for all services. Now, after a user defines their values in the chart, what happens is in the CI process, we are using GitHub WebSockets API, and we are just processing all of those charts. We're packaging them. We're doing Helm package, and we upload these packaged charts into JFrog Artifactory. Now, for those of you who are not familiar with JFrog Artifactory, I'll just say that it's a artifact registry, and this is our chart management registry, and it's actually a single system for artifacts, which allows searching and tagging, and we actually use that for other purposes in Forder. So it was just easy enough to also send the charts there. It helped us with versioning and version control. And the next thing that we did was having Argo CD to watch for changes in JFrog Artifactory. And that was pretty easy to manage. Now, I know that I didn't talk at all about our solution for CD, which is Argo. I can say a few words about that because I think it will be kind of insightful. So because we had that in-house Python DSL, what we used to have so far was just Jenkins jobs that were doing the cloud provisioning for the instances, and actually that's just the deployment, right? And we wanted something that will be easier to configure, that will be more flexible for changes, and that's why we went with Argo. And so the way it works, just like I already said, is that Argo is watching for changes in JFrog Artifactory in the charts, and then it is doing the sync to Kubernetes, and that's it on this side. Now, I think that this part is pretty big to talk about, but I still have enough time, so I will elaborate on that. So, what you can see over here is the repo of where we generate the cloud formation templates. It's the same Python infrastructure as code, Python DSL that I already talked about so much in this talk. So, this is where we generate the cloud resources. So, another thing that we decided to do was to generate values YAML. So if you have like Terraform in your company, or if you're using Pulumi and you don't want to integrate Helm into that system, or you don't want to generate the Kubernetes manifests on your own, but you do need some values to come from the cloud, from those templates, or for example, let's say the AWS ARN, or maybe like a queue URL or queue name, because we are generating all the AWS queues in there. So I need those values to be in my Helm charts. So the way that we did it is we defined that in a values YAML, and then we provisioned that into Argo CD. And then Argo, when it's doing the actual deployment, it can combine a few values YAMLs with the same deployment, with the same chart, and it will just override the needed values. And what you can see over here, that's the complete solution that we have at Forder. We already started with we are well into the migrations now. And I can tell you that it's not a walk in the park, but it's manageable. And I hope that, I gave you enough confidence to even try and do it yourself. And with that, I will say thank you.
Wow, it was great. Everything's okay?
What?
How you feel?
Oh, yeah, I feel great. It's kind of difficult not seeing people smile. I'm wondering if I smile to myself all the time, or if somebody laughed. Did you laugh?
I did. And
Okay.
I thought I was like smiling. So nice.
Okay.
So
Good.
many positive energy. So yeah, I was like,
Yeah.
yeah, I liked it a lot. So everyone who still here, you are more than welcome to ask questions. There is a Q&A section chat, so start asking, and we will see and continue. By the way, there is a little bit of delay between when we're talking and when actually people sees it. Okay. So let's spend this time till the questions will come. Okay. By the way, you said about the everything behind you. It's not a virtual background. It's a real one. It's like this is a
real
reality.
things. Like I can do a little show off. Like I have a real gateway color here. I have a Tamagotchi here. I have a whole bunch of things. So
Oh, and you have the old Tetris, I see also, right, or something like this.
yeah, I do, and I also have like this Super Mario watch. I don't know. It's crazy. Like I have a lot of crazy things. These are not shoes, by the way. These are speakers.
Cool.
Yeah, that's my computer speakers. Anyway, yeah. Jenkins is waiting here. I have JFrog waiting here. I have everyone, all of my friends. They're
And
here.
where's the octopus?
I don't have. Oh yeah, I should have had an octopus. This should have been a good idea. I do have Darth Vader in every shape and form. I even have like a duck, Darth Vader. Yeah. If anybody has like serious questions, that's the good time to do that.
Yeah. Okay. So
I can go on and on forever with my toys.
Great. So I'll start the question. I'll ask one question by myself. As to waiting for the guys, girls who will write more questions. You said so. After all the implementation of Helm in the company, how the developers reacted on it? Are they like it? Are they it's become easier for them?
Yeah. So it's actually a very good question. It came up in the past few months that we started doing the migrations. So I was actually very surprised with the reactions to Helm, because although I knew that they weren't big fans of the Python DSL that we had, but we needed, by the way, we needed that Python DSL because we have multi-cloud environment. We have both AWS and Azure, and we needed like complex support for both of those. So that's why we have that in-house Python DSL. So, and the developers, they're supposed to be familiar with that Python code because they've been working with that all the time. That's how they define their cloud resources. It's very powerful, but it's also kind of complicated. But then when they started to go with Helm, I was sure that they will be like, oh, it's new, it's annoying, then I don't know. But there were good comments. They said that there was enough information out there, that it was easy to debug because they can generate the chart locally and see that, see what's going to be deployed later on, and they could actually understand the different parts of the chart and the final manifest that is being generated by after the rendering. And yeah, that we got good comments on that. The harder part of the migration actually came from the Python DSL, but it's also because we defined there the service mesh, and that's a big thing on its own. So let's
Yeah,
not go into that.
I see. Okay. I like to talk very much.
Thank you
Uh,
so much.
and I hope to see you soon on different conferences. You have another conference, right, coming up?
Yeah. If anybody's going to Sweden tomorrow or the next day, come say hi. I will be there in Sweden in Devsum. So come say hi.
Great. Okay. Hold on. We have a question. I'll
Okay.
just I'll just copy paste it over here, and I will read it. Okay. Do you manage config files, values files for different environments as a separate configuration artifact, or bundle them together and upload to artifact repository along with the Helm chart?
So actually, that's an amazing question because this is one of the things that we had a lot to think about. Currently, we define the different environments, and so we have different AWS accounts. We have different regions, and we have different cloud provider, different accounts in each cloud provider, different regions, and then different environments in each of those. So there are a lot of options over here. So we do have the separations for the cloud provider account regions, and also for dev and environment, and for prod environment. Um, we have that in separate files for the in the Helm charts. So every Helm chart will have like a few values YAML, and also we have those separate files over here where I said in the cloud formation templates values YAML, we also have it separate over here for like the region, the account, and the environment. Yeah, that's how we do that.
Great, thanks. And here's another one question very related to the previous one. Do you have a separate repository for the infrastructure related Helm charts, like Prometheus, Ingress?
Okay, so that's another good question. So, for example, all of the matrix, like Prometheus, for example, we still have that in the Chartmender repo, which is that one over here that I mentioned. And for the Ingress stuff and other infrastructure, we have that in the cloud formation, like over here in where I wrote cloud formation templates and the values YAML. Those things are actually decided and rendered in this repo, because we said that whatever is related to the service of the repo will be in the repo. So for example, the deployment YAML is there, um, And things that are related to the infrastructure, we left it to be defined in that one repo that we already have with the Python DSL.
Great. Okay, let's see if there's any other questions. No, there's none.
Okay.
Thank you very much.
Yeah, thank you so
Really
much.
enjoyed it, and I hope we will meet in other conferences too. And also,
Same here.
we both live in the same country, so
Yay!
definitely, yeah.
All
Okay.
right.
And, thank you, and have a good day.
Thanks everyone for joining. Bye.
Bye.